Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about compound interest. So, linking to what we've previously done, in the simple interest video I showed you how to calculate that, and at the same time actually showed you how to calculate compound interest. So would you pause the video and just double check you can do the questions about Dan having money in a bank account at simple interest, and then do the same question with Dan having his money at bank account with compound interest. Pause the video and then I'll go through. Okay, here are the answers. This is what I would expect you to have been able to get. In the simple interest case, you work out 4% of 6,000, and then he gets that amount, £240 every year for 3 years. So you should have got £6,720 in his bank account at the end of 3 years. Whereas in the compound interest case, it's much better for Dan. He gets interest on his interest, and you would do 6,000 multiplied by 1.04 multiplied by 1.04 multiplied by 1.04 to get how much he's got. Now a little note here that we're going to find useful in the video. Multiplying by 1.043 times, we can write that as 6,000 multiplied by 1.04 to the power of 3. So that means that multiplied by itself 3 times. Look in the index notation section for more details on that, but henceforth in this video I'm going to write it like that because mathematicians are lazy and it's a quicker way of writing it than that long multiplication there. Okay, what's this video about? Basically, this video is all about compound interest. So doing some more questions a bit like that, but then building it up into questions, in exam style questions where they compare simple interest and interest rates, etc. So let's start. For each one, I'd pause the video and have a go yourself first. Okay, Dan has this amount in a bank account. It's paying him compound interest at that rate, and how much will Dan have after 3 years? If you know how to type it in and use decimal multipliers, it is one line of working. So it's his original amount, 5489.23, multiplied by, now for an increase or an interest rate of 2.89, you'd multiply by the decimal multiplier 1.0289 to the power of 3, because we want 3 years. So you go and get your calculator out and you press 5489.23 multiplied by brackets 1.0289 to the power of 3, and there you go, you get the following answer: 5979.032717, and we're going to round to 2dp because it's money, and say that Dan has at the end of it £5,979.03, and there you go, a nice straightforward compound interest problem. Let's try another one. Pause the video and have a go. Now, this is actually a question we've talked about previously on repeated percentage increases and decimal multipliers, so look back at that if you're not sure. Sarah puts all her savings into a bank account, given her interest of 12% each year. She keeps her money with that bank for 4 years. By what percentage has her savings increased? Give your answer to 2dp. Now, we don't have an amount for Sarah, but we don't need it, because a 12% increase, let's think about that. If you have 100% and you increase by 12%, you have at the end 112%, and as a decimal multiplier, that's 1.12. We've used those in the previous examples. Now, if you are going to increase by 12% in each of 4 years, assuming compound interest, okay, we're going to multiply by this 4 times. Alright, so whatever our amount is, it doesn't really matter. Our amount here, we're going to multiply by this thing here 4 times, or 1.12 to the power of 4, and it will give us our new amount. Now, if we actually type in our calculator 1.12 to the power of 4, it tells us that answer there, which, let's write that down. So we would have had our amount multiplied by 1.57351936. Now this here indicates to us a percentage move in one go. What percent increase has our amount increased by? And 1.5735 indicates a 57.35, and I've been careful there to think of the rounding, percent increase, doesn't it? Okay, just in the same way, if I had got the answer 1.20, I know that's a 20% increase. If I got the answer 1.23, I know that's a 23% increase. And if I got 1.237, I know that's a 23.7% increase. So just by looking at there, I can say that's a 57.35% increase. So that's how much her amount has increased by. So 1.12 to the power of 4 is the same as a one move 57.35% increase. Now do go back and look at repeated percentage increase and decimal multipliers videos. There was loads of these examples we did. Right, let's try another question. Typical question you'll see in a book here or an exam. Sarah wants to invest £3,000 for 3 years in the same bank. She doesn't want to have a bit in one bank and a bit in another. The big bank offers her 4% for the first year and 1% each year after. The small bank offers her 5% for the first year and 0.5% each year after. So at the end of 3 years, Sarah wants as much money as possible, don't we all? Which bank should she invest her 3,000 in? So let's think. The first year, her decimal multiplier in the big bank is going to be 1.04. And for years 2 and 3, the remaining 2 years, her decimal multiplier is going to be 1.01, isn't it? And let's go over to small bank. For the first year, her percentage increase is going to be 5%, so the decimal multiplier is 1.05. But then for the second and third year, we're going to have a decimal multiplier of 1.005. Okay, that indicates a 0.5% increase. So let's compare the two. Let's write how much you'll have in big bank. So make sure you label it up. Big bank, she will have £3,000 multiplied by 1.04 for the first year, multiplied by 1.01 squared, because there's 2 more years for each of the 2 other years, and that will give us our amount. Now the calculation for the small bank, what's that going to be? Well, it's going to be £3,000 multiplied by 1.05 for the first year, and then multiplied by 1.005 squared for the other 2 years. So all we've got to do is tap that into our calculator, and see in which case Sarah has more. In the first case, we would get 3182.712, which if we round to 2dp, that's £3,182.71. And with the small bank, I get the answer 3181.57875, which again, if we round to 2 decimal places, that's going to be £3,181.58. Now, there's not much in it, is there? But which one's better? Big bank's better. Always state your answer. Sarah should invest in the big bank. And there we go. Done. Okay, one more question to think about that's slightly harder and more difficult. Colin puts £5,000 into a bank account at 6% interest a year. How many years does it take to have over £10,000 in his bank account? So this time we don't know how many years Colin's going to invest in, but we know we want him to have over £10,000. So let's set up what we usually do. The usual calculation would be 5,000 multiplied by the percentage multiplier for a 6% increase, which is 1.06. Now this time we don't know how many years, but we know that we want to get an answer over £10,000. That's what we want. So what do you think you should do? Well, get your calculator out and try the number 1, 2, 3, 4, and keep trying numbers until you get the first time over 10,000. So let's give that a go. So calculator out, 5,000 multiplied by 1.06 to the power of. Put in 1 there. It's clearly not 1. Okay, now I'm going to guess a bigger number. 1, it was nowhere even close. So I'm going to guess 6, let's say. Right, and I get 7,000. That's not even close. I'm going to go and guess 8. Oh, still quite a way off, so I'm going to jump a fair bit. 12. Okay, oh, we're just over it there. We're just over it. Let me just check 11 didn't make us over it. No, it didn't. 11 was just short. So I found the answer was 12 years. So we're going to tell the examiner that we found that. and we got ourselves the answer £10,060.98. Therefore, the answer to the question is it takes 12 years. And that's a quite tricky question, but if you just keep your wits about you, it's not too bad. That's it for this video. Thanks for watching.